Hi students, today we will discuss about storage class. Before going to the actual concept of storage class, at first we need to know the use of storage class. For that, we will do a small recap about variable. A variable is actually the name of the memory location. It is used to store data. Every variable in C programming has two properties. The first one will be the type and second one is storage class. So the type, it refers to the data type of a variable. We know that at the time of variable declaration, before the name of the variable, we will put the data type. The data type will give an idea about what type of value we can store inside the variable. The second one is storage class. It determines the scope, visibility, lifetime, and default initial value of a variable. So we goes to more details of storage class. At first, the important properties of storage class are scope, visibility, lifetime, and default initial value. The first one is scope. It gives an idea about the region of a program in which a variable is available for use. The scope will explain at what region a particular variable is active inside a program. Some variables will active throughout the program. Some will active only inside a function. Then other possibilities, some variables will be active a particular block in the program. Then next one is visibility. The program's ability to access a variable from the memory. That is visibility. Then third one is lifetime. The lifetime of a variable is the duration of time in which a variable exists in the memory during execution. And the last one is default initial value. That will give an idea about if we do not explicitly initialize a variable, what will be its default initial value. Next, the types of storage class. There are 4 types of storage class in C. They are automatic variable, external variable, static variable, and register variable. Before going to more details of types of storage class, we will see how we can declare a storage class. For declaring a storage class, we have to follow a particular syntax, that is storage class keyword, then data type, then variable name, and after that we will put a semicolon. So for getting an idea about the keyword of storage class, consider this table. This table contains 2 columns. The title of the first column is storage class and the title of the second column is keyword. So the first storage class is automatic, its corresponding keyword is auto. Second storage class is external, its corresponding keyword is extern. And the third one is static, its keyword is static. And the fourth storage class is register, its corresponding keyword is register. So we again move to the syntax, that is storage class keyword, then data type, then variable name, then at last we will put a semicolon. So for explaining the syntax, consider some examples. First example is auto int a, then a semicolon. Here this auto represents the keyword of the storage class automatic. Then in this the data type of the variable a, and a is the variable name. The next example is register float count. Here register is the keyword of the storage class register and float is the data type and count is the variable name. And the last example is extern int m. Here extern is the keyword of the storage class external. In this the data type and m is the variable name. Next we will discuss more about the types of storage class. I am already discussed there are 4 types of storage class in C. They are automatic variable, static variable, register variable, and the last one is external variable. In that, at first we will discuss about automatic variable storage class. So here at first we will discuss the properties of automatic variable storage class, and that first one is scope. Variables which are defined within a function or a block. That means the scope of automatic variable is only inside the function or the block that variable is defined. The next property is lifetime. The lifetime of the variable will be till the end of the function or the block where the variable is defined. Then the third property is default initial value. So the default initial value of automatic variable will be a garbage value. Then in the case of automatic variable, we have to keep in mind some points. In that, the first point is these variables are also called local variables because these are local to the function. That means the automatic variables are also called local variables because they are local to the function. The second point is variable declared inside a function without any storage class specification is by default an automatic variable. That means if we declare a variable inside a function without giving the storage class specification, that variable will automatically comes under the automatic variable storage class. For giving more ideas about the automatic variable storage class, we need the help of a particular program. So consider this program. So this is the header file of the program. After that, here we will use a function. The name of that function is test. So here we write the function declaration of that particular function, that is void test. Then we'll put a semicolon. Then next we comes to the main part of the main section of the program. So inside the main section here we call three functions. That is, the first function is test, then again we call the same function, then again we call the same function test. So at first we move to the first function called, that is test, we put a semicolon. When due to the effect of this first function call, the control will comes to the function definition, that is void test. So inside this function we declare the automatic variable a. So the declaration is auto int a, then that is equal to 0. That means we declare the automatic variable a and the value now present inside the variable a is 0. Then we will increment that value present in the automatic variable with the help of the statement, that is a is equal to a plus 1. Now the value present in the variable a will be equal to 1. Then that value will be printed with the help of printf function. So the output will be 1. So this curly bracket indicates the end of the function. Due to the end of the function, the automatic variable a will also dead. Then again the control will comes to the main function. Again the same function will be called. So the control will comes to the function definition. Then inside the function again the automatic variable will be initialized. Now the value present in the variable a will be equal to 1. Then that will be incremented due to the effect of the second statement, and that value will be printed. Now the print value will be also 1. Then this curly bracket indicates the end of the function. Due to the effect of this curly bracket, the automatic variable a will also dead. Again the function call will happens. Again the control will comes to the function. Here also, here again what happens, the variable a will be declared. Now the value present in the variable a is equal to 0. Then again the value will be incremented. Now the value present in a will be 1. Then that value will be printed. Then the output will be 1. What we have to understand from this program is, the point we have to remember in the case of automatic variable is the lifetime of the variable will end when the function or block where the variable is defined is end. Next, we will discuss about the static variable. So at first we will discuss about the properties of static variable. First one is scope. The scope will be the variables which are defined within a function or block. That means the static variable will active only inside the function or block where the variable is defined. The next one is lifetime. That is, until the completion of the program, the variable will alive. Then the third one is default initial value, that is 0. Then in the case of static variable, we have to memorize a particular point, that is the static variable is initialized only once and remains into existence till the end of the program. For explaining that point, we need the help of a program. So consider this program. This is the same program we used for explaining the automatic variable storage class. So consider the program. At first we write the header file. After that we do the function declaration. Then we comes to the main section. Here we calls the same function 3 times. So consider the first function call, that is test. Then we put a semicolon. To the effect of this function call, the control will comes to the function definition, that is void test. So inside the function, at first we will declare the static variable a. So that is static int a, that is equal to 0. Now the value present inside the static variable a equal to 0. Then that value will be incremented with the help of the statement a is equal to a plus 1. Now the value present in the variable a is equal to 1. That value will be printed with the help of the printf function. So the output will be 1. Then that is the end of the function. Then the control will comes to the second function call, that is test. Again we will put a semicolon. So what happens is the control will again comes to the function, that is void test. So inside the function again the declaration section comes, but in the case of static variable, that declaration section will not take place. That means this statement will not work. Then this next statement, that is a is equal to a plus 1 will work. So in the case of the statement, the previous value present in the variable a is 1. So 1 plus 1. Now the value present inside the variable a will be 2. That value will be printed with the help of this printf function. So the output will be 2. So this is the end of the function. Then again the control will comes to the third function call. So again the control will comes to the function definition. Then again the statement in the body of the statement will be read. Inside that this function declaration will not takes place. The control will directly comes to a is equal to a plus 1. Previously in the value present in the variable a is 2. That 2 plus 1. Now the value present in the variable a is 3. That value will be printed. So due to the effect of this program, what we have to understand is, in the case of static variable, the static variable is initialized only once and that will be remain till the end of the program. Okay. Then next we goes to the register variable storage class. So next title is register variable storage class. In the case of register variable storage class, we have to consider these 2 points. The first point is the register variables informs the compiler to store the variable in CPU register instead of memory. That means in the case of register storage class, the data will be, the variable will be present inside the CPU register. The next point is the access time of the register variable is faster than automatic variable. Then the properties of register variable storage classes. The first one, scope. The variable will be active only inside the function or block where the variable is defined. Next is lifetime, till the end of the function or the block. Then default initial value will be a garbage value. Then we comes to the fourth storage class, that is external variable. The external variable storage class is also known as global variable storage class. At first, we will discuss about the properties of external variable storage class. In that, first one is scope. I'm already discussed the external variable storage class is also known as global variable storage class. So global, that means everywhere in the program. These variables are not bound by any function. They are available everywhere. The next is the lifetime. Till the program doesn't finish its execution, you can access global variables. Then third one is default initial value. The default initial value of external variable is 0. When we are studying external variable, we have to remember two important points. In that, first one is variables that are declared outside of all functions are known as external or global variables. Second point is they are accessible from any function inside the program. For discussing these 2 points, we need the help of a program. So consider this program. This is the header file of the program. Then here in this program, we use 2 functions. The name of the first function is fun1. The name of the second function is fun2. So these 2 are the function declaration of the function fun1 and the function fun2. Then next point is I'm already discussed when we use a particular variable as a global variable, we have to declare that variable before the starting of all the functions. So here the variable number is a global variable. Due to that reason, we declare the variable number here. That is int number. We put a semicolon. That means this variable number is a global variable. Then we comes to the main section. Inside the main section, we initialize the value of the variable number, that is number is equal to 10. Then we will call the printf function. Then with the help of the printf function, the data present in the variable number will be printed. So this will be the output. The output will be 10. Then after that, we will call the first function, that is fun1. So due to that function call, the control will comes to the first function. Then inside the function fun1, again we will put number is equal to 20 and that value will be printed with the help of the printf function. So the output will be 20. Then again the control will comes to the main function, main section. Then again here the function called, the second function is called with the help of this function called, that is fun2, and we'll put a semicolon. So the control will comes to the second function. Inside the function, we will have a printf. With the help of that printf function, the value present in the variable number will be printed. So the output will be 20. From this program, what we understand is when we declare a variable as a global variable, that will be active throughout the program. Next, we will do a comparison of different storage classes. The first storage class is automatic. The keyword of that storage class is auto. Its scope is within the function or block. Lifetime is function block only. Then visibility is local and its initial value is garbage. Then next we move to the second storage class, that is static. Its corresponding keyword is static. Its scope is within the function bar block, that is same as the automatic variable. And its lifetime is throughout the program or whole program. Then visibility is local and its initial value is 0. Then we move to the third storage class, that is register. Its keyword is register and scope is within the function bar block. Then lifetime is function block only and its visibility is local and its initial value is garbage value. Then we move to the fourth storage class, that is external storage class. Its keyword is extern and scope is entire program and its lifetime is throughout the program and visibility is global and initial value is 0. So this is the end of this section. Thank you all.